Again, good morning. Thanks for taking time out of your day. My name is Steve Brown with AAP Automation, and we're really excited to host a predictive maintenance webinar presented by Dan Anderson with Omron. If you have any questions, please wait until after the presentation. With that being said, I'll turn it over to Dan.
Thanks so much. I really appreciate it. As mentioned, my name is Dan Anderson. I'm a product manager for Omron for our components product line, and today I wanted to talk a little bit about some of the predictive maintenance offerings we have and kind of how predictive maintenance can, quite frankly, save your company's money. So kind of going into this, what we're going to talk about today is I wanted to make sure that when we talk about predictive maintenance that we're kind of just defining our terms of what does that actually mean. And then obviously the real question is how is predictive maintenance going to save you and your company money? Why do you want to work with Omron regarding predictive maintenance? And then we'll actually talk about the specific predictive maintenance products that we have within our offering, right? The solutions that we have. And then last but not least, we'll actually go into some questions that may come up at the end of all this. So first things first, what do we mean when we say predictive maintenance, right? So when servicing equipment inside of a facility or a manufacturing facility, a factory, it used to be that you would run products to failure, right? Obviously, this was kind of before we kind of really knew a whole lot about maintenance and whatnot. And then we switched over to time-based, right? Every 6 months, we're going to inspect this three-phase motor and we're going to determine if the bearing is in good condition or if it needs to be serviced or whatever, right? We're basically making a time-based decision of maintenance, right? Now, what we're talking about when we say predictive maintenance is we're talking about condition-based service, right? We're talking about actually taking measurements of readings on the machines themselves and then making decisions of maintenance based upon those readings, right? And so some of the products that we have will actually get to a point where it will predict when your equipment needs maintenance, and it actually gets to a point where it will be able to reduce the frequency of needed inspections because you'll know when, rather than having just kind of a time-based frequency, you'll actually know when the condition of your equipment needs service. And so this obviously kind of translates to lower costs over time by reducing the need for frequency of inspections. And obviously, if you're going to save something from potentially failing, that's another area where it's going to save you money as well. So how does it actually save your company money, right? So it kind of just piggybacks off of what I just said. If you have equipment that's ends up failing during production or while you're doing something, this is going to be unplanned downtime. And the measurement that we got, the feedback we got from the industry is that approximately 82% of all companies experience unplanned downtime. That unplanned downtime cost is going to vary wildly from industry to industry. We're going to talk about a real world example with an automotive supplier where their unplanned downtime was over $700,000 an hour, right? So it's going to vary from company to company, but it's a cost nonetheless. And one of the things that predictive maintenance is going to help you do is reduce that unplanned downtime cost by basically doing, like we said, service, condition-based service on your products in, planned downtime where you don't have all your workers on the line, you're not paying everybody. It's a situation where you have the ability to change things out without impacting production. In addition, so aging equipment can be expensive to maintain. And so if you can get to a point where you are now servicing that equipment based upon condition, you can overall help reduce the cost to maintain a lot of those pieces of equipment as a result of knowing exactly when it needs to be serviced. And last but not least, in order to maintain all that equipment, you actually have to have people walking around the floor, taking readings and making judgments based upon, what kind of maintenance needs to be done. And so we kind of consider that to be a skilled laborer position, and especially at a time right now with COVID where skilled labor is kind of in short supply and demand seems to really be roaring back. This is another area where it's kind of a cost that, or should I say a demand that there is a lack of supply in. So it's another area where Omron predictive maintenance offerings can help address these problems and help save you money as a result. So this is the complete product line offering we have in predictive maintenance. There's actually 6 products here, even though you only see 5. These 2 have a very similar monitoring system, so I'm kind of counting this twice. But first and foremost, I wanted to talk about our power supply. So this is the power supply that you've kind of known and loved from Omron for a really long time. We've been making it for over 30 years. But we've increased the amount of features on this product where you can now actually connect this power supply up to the internet, and you'll get a live condition feed of what's going on inside of the power supply. And I'll give you some more details on specifically what that actually looks like after I go into a real world use case where we partnered with a global automotive manufacturer up in Detroit who is actually experiencing power supply failures on their manufacturing line, right? As I mentioned, it's very expensive for automotive manufacturers to have unplanned downtime since they have all the laborers on the line. Everything is waiting. They calculated their cost to be around $765,000 an hour, right? So if a power supply goes down, maybe it takes them 5 to 10 minutes to replace it. That's still, $60,000 to $70,000. Actually, I think it's $100,000 if I did my math right there. So if you were to get to a point where you had some knowledge of the remaining lifetime on an S8 VKX power supply, and that prevented a unplanned downtime scenario in this situation, you can see how that return on investment very clearly pays for itself, right? Or should I say those features to be able to see the status of that power supply end up paying for themselves. So this automotive manufacturer learned about all the monitoring features, which we're going to cover in the next slide, associated with this power supply. And that basically got them to a point where they determined the frequency of failure times the cost of failure versus the ability to catch it with this S8 VKX power supply gave them an average return on investment of approximately 18 months for, essentially buying these power supplies and having the ability to monitor that and offsetting any sort of unplanned downtime that they may have impacted them as a result of a power supply failure. So really cool, really interesting real world scenario where you see that play out. So as I mentioned, these power supplies are very similar to the power supplies we've been making for a long time. And of course, all of them have a 5-year warranty on it. But basically, we've been able to get to a point where we've added Ethernet ports so you can monitor the status of this power supply anywhere in the world that has an Ethernet connection, right? So basically, it's just TCP/IP. They also have a display on the front of them so it can show the status. If you don't want to connect it up to the Ethernet, you can still see the status of all of those variety of status conditions that we're going to cover in the next slide on the front panel of this power supply. So that's another great way to be able to just see the status. So it comes with a free monitoring software where after you plug this into the internet, right, or you can plug it directly into your laptop, you can actually monitor up to 18 power supplies in parallel with each other, right, at the same time. And so what can you actually monitor inside of here? Well, you can monitor, current voltage, output current, what is the maximum current that you've drawn in the past, how many years until the product needs to be replaced, and what's the total runtime. In addition to that, you can also set alerts and alarms, right? So if something gets to a point where it's outside of what you want it to be, let's say your voltage has dropped to 22.5, you can set an alert that says anytime your voltage drops below 23 volts, send an alert. You will get a red exclamation point that comes up on the screen and says something is outside of that specification that you have defined it to be, right? So it's basically live condition feed of the power supply along with alerts if anything kind of gets out of an area that you want it to be. You can define all of these things. Each of these things can be programmed with some sort of an alarm where you can have a very specific condition. And then it'll also graph all these things over time as well, right? So it'll show you kind of what's been going on with your current or your voltage over the last, week and a half. Along those lines, you can change the sampling rate. There's a lot of neat little features you can kind of mess around with in the software to get exactly how you want it to be. So next product that I wanted to talk about was what we call our K6CM product line. And this product line is specifically dedicated to the monitoring of three-phase electric motors, right? And so we have 3 different products in this 3-phase motor condition monitoring, where we're going to be measuring vibration and temperature that's associated with bearing wear. You're going to be monitoring current abnormalities associated with overload or maybe even like pump cavitation or something like that. And then also insulation resistance associated with basically a short out or, having motors being exposed to solvents, lubricants, anything that would deteriorate the insulation around the wires being used inside of that 3-phase motor. So today, this is a very manual inspection process, right? People are going to go around the factory with their tools. They're going to take measurements. It's going to take some time. You're going to be spending, essentially labor resources, which is cost on doing these things. So We had a particular scenario that we're going to go through on the next page where our customer stated that it cost them about $2,000 a year to maintain each motor that they had. And if one of those motors failed, it was about $16,000 to pull that motor out, purchase a new motor, and replace it. All the labor, all the time, all the cost. That's just the numbers that they use. Obviously, this is going to vary wildly in the industry based upon the types of motors that you're going to use. But what we're kind of moving towards, what we're suggesting is basically getting to a condition where you can remotely monitor the health of all of these motors, and then you can get real-time status alerts of any abnormalities that may happen. You can set up alerts and alarms when things get outside of spec, and then you can service that motor based upon condition, right? Because you've been measuring its condition over time. It's going to reduce your reliance on skilled labor resources, which is ultimately going to result in a cost savings to maintenance, right? So here's a real world story, real world scenario where we actually partnered with a hospital up in Canada where they had a bunch of unexpected failures of their three-phase motors in their HVAC systems, right? Their circulation systems within the facility. And so as a result, they were spending about $2,000 a year for each motor that they had in that HVAC system. And like I said, they were saying it was about $16,000 if they had to replace one of those motors. So the K6CM vibration and current models are basically the right thing to use in this scenario where we would be monitoring vibration, temperature, and current draw of those three-phase motors. And that gave the maintenance crews the ability to actually have real-time information, real-time status and condition of those three motors that they attach these to. So they installed 9 of these vibration sensors into the 3 air handling units in their facility, and they were able to monitor basically the status of the motor bearings as well as the drive bearings in the fan, and then any sort of overload condition that they were having occur in that motor, basically, as it operated, right? You can imagine how, especially kind of in the time of COVID and like a hospital, if you have a circulation system failure, with an airborne virus of some sort, it would be, you could see how a situation like that would cascade into a potential resulting of loss of life if it were severe enough, right? So in this particular scenario, based upon how much money they were spending per year to maintain motors versus the installation cost, they calculated their return on investment to be 15 months in this particular situation. So really neat application. So, and I wanted to just kind of show it real quick. So obviously they installed this vibration sensor on top of the motor, and then they ran it all to a see-through control box right here. So they had basically live feed of what was going on with those 3 motors. And then these are all connected to the internet. So they had a laptop downstairs in the maintenance room outside of where all this stuff is. And so they could basically get a live feed and monitor everything associated with what was going on in the condition of those motors without even being upstairs in the facility, right? Really cool stuff to do. So the other one that I wanted to talk about, this is the current model, right? And so as I mentioned, essentially all 3 of these products are all based upon monitoring the health of 3-phase motors, right? That's their primary intention, is basically addressing the primary failure modes associated with bearing wear, overload condition, cavitation, and then insulation resistance breakdown as a result of just being exposed to, contaminants in the environment, solvents, lubricants, anything that would break down the insulation on a wire. So this particular product is the current condition motor, or current condition monitor, where it actually has algorithms inside of this monitoring unit that will monitor the sine wave of the electrical wave that's going inside of this 3-phase motor, and it will end up detecting any sort of abnormalities, right, specifically associated maybe with pump cavitation or anything where you're going to be outside of what you would be expecting that motor to do in terms of current draw. And the way that this works is it's just a CT clamp. It attaches to one of the wires there on that 3-phase motor. So it's a very easy install. There's no cutting of wires or anything like that. It's really just putting this clamp on top of the wire and then putting this inside of a control box and then just wiring everything up with power and then connecting it to the internet. It's really as simple as can be. Bunch of different versions of size and amperage draws that you can select from in terms of how big of a motor you have. And then the last one in this K6CM series is the insulation resistance monitor, right? So this is very similar to the other products, but in this time, what we're doing is we're actually monitoring the insulation resistance of the wires inside of this to specifically prevent the scenario where you've got a short out and then basically a burnout of the motor as a result of shorting. And so how does this work? It's got a 0 current transformer clamp where all 3 of the wires going into the 3-phase motor are basically contained inside of this. And then it measures current leakage associated with that, and then it's able to determine insulation resistance as a result. specifically any sort of breakdown of the insulations based upon excessive heat or foreign debris. And then it'll even give you a trend. We'll kind of go into the software here a little bit on the next page. You can do any three-phase motor up to 7.5 kilowatts, 300 amps, using this ZCT clamp. And then, as I mentioned, it has an Ethernet IP connection on it, so you can basically monitor it anywhere that has an Ether connection in the world. So if you wanted to send this to a corporate headquarters or something like that, or some other location, you have the ability to do that. And then, as I mentioned, there's an actual software that connects with this as well, in addition to the actual product, having features inside of it. And this software will allow you to monitor up to 10 motors, and then all three of those different products we talked about, the vibration and temperature sensor, I think it's called the K6CM VBM. We've got the version that's going to do the current draw, right, the K6CM CI. And then we have the version that has the insulation resistance on it, where you can actually monitor all three of those different products all simultaneously from the same software, right? So up to 10 motors all at the same time. Really cool. So it's a great way to monitor the health of three-phase motors comprehensively. So I have another product here that is very similar to the one that we just spoke of, right? Because, we just talked about the insulation resistance monitor. Why are we talking about another one that's measuring insulation resistance? This one is very similar, but it's a little bit different. And I thought it was different enough where I wanted to actually cover it and just mention that it was an option, right? So this is the K7GE, and it's similar to the K6CM in that they both measure insulation resistance. But remember, everything in that K6CM series is all for three-phase induction motors, right? So up to 7.5 kilowatts. So it's really only going to be used for anything that's three-phase. Where this is different, that K7GE, you can monitor the insulation resistance of any motor of any size of any type, right? So you can do servo motors, single-phase motors, three-phase motors, any motor whatsoever, right? It has nothing to do with the type of motor that you're actually measuring. And the reason why it's different is because the methodology of how you are measuring is going to be different, right? This K6CM, it's very simple. It's just a clamp. All the wires go through there. You close it, you wire everything up, you're good to go. This K7GE is actually a hard line into the actual motor itself, or whatever it is that you're measuring. And so the installation process is a little bit more involved, but you can measure more stuff, right? You can measure different types of products, single phase, three-phase servo motors. And then it also allows you to add additional probes, so you can go up to 8 motors per monitoring unit, right? Whereas with that K6CM, it's 1 unit for every motor, and so it's basically a 1-for-1. If you were in a situation where you wanted to monitor a lot of motors, essentially up to 40 motors, this would be a better fit for you rather than something like this, right? So it's kind of used for a little bit of a different scenario. One of the other things that I wanted to point out real quick is that, well, this product right here has an Ethernet IP connection on it. So like I said, you can get it anywhere in the world where you've got an internet connection. This one has an RS-485 output. So you would either want to connect it to a PLC or an HMI or even a converter interface if you really wanted it to get to like an IP out where you could get it anywhere else in the world. So it's a little bit of a different application, very similar. And I wanted to make sure that I made the distinction between the two, since we just talked of one about, how do you measure insulation resistance, right? Similar products doing different things, offering different features. So I wanted to talk about a real world scenario where we actually had a customer of ours over in Japan, automotive manufacturer, had multiple motors fail over time. And so they have multiple different areas in their facilities where they have CNC machining areas. They have, obviously the transport gantry cranes as you have receiving docks. And then they also have a plastic injection molding area as well. And so, excuse me. What they did is they attached this K7G insulation resistance monitor to the motors inside of the CNC machines. And then obviously you can see how having a failure occur of a three-phase motor up on the ceiling would prove challenging to replace or service that if it actually got to a condition where it failed. So you could see how that would really pay for itself, even in one instance of failure, if you could determine there was an issue with insulation resistance that needed to be addressed, right? Basically kind of predicting that maintenance ahead of time. You could see how that would really pay for itself. And they were also actually able to use it on the heater in this condition. They were using it to basically measure the insulation resistance on the wires that were going to the heater that was used in this injection molding press right here. So real world scenarios where a single automotive manufacturer used it in 3 different sections of their facilities. And then as the same as the other ones, there's a monitoring software as well that allows you to actually kind of keep track of where those measurements are happening. You can schedule those measurements to be automated over time, so you'll get a trend and you'll be able to determine, hey, we're at a point where this three-phase motor needs to be serviced, right? It's really great, really nice thing to be able to have that information at hand, and then you can make decisions based upon condition rather than simply time or whether or not there's smoke coming out of that motor. So last product on the list here, and this one's my favorite. This is really interesting, is called the K6PM. This is a thermal condition monitor, and really what it is it's just basically a thermal camera that connects to this monitoring device, and then obviously all that information gets to go out over that Ethernet connection where you can see the actual heat condition of what's going on inside of wherever it is that you're monitoring. So looking at a real world example of where we use this, we have a partner over in Japan, basically a supplier to the automotive industry, where they have a paint station, and then obviously they have duct working to basically kind of vent the hot air that they're using to dry that paint. The facility that they had was kind of older, and so there was some deterioration of the insulation around that ductwork. Eventually, that deterioration had some heat loss and leakage of heat, causing a fire at one point, right? And so then they had to go to basically a manual inspection scenario where they were walking around the facility, making sure that all of that ductwork associated with venting the heat from the paint station got out and none of the insulation deteriorated such that it would cause a fire or anything like that. They were calculating each thermal inspection cost them about $2,500 per inspection. So they would have an individual walk around the facility, basically taking laser measurements of any of the areas where they had all this duct work, and just to basically make sure that they didn't have a fire occur again, because those are expensive. So what we did is we partnered with them using the K6PM product, and they installed 50 of these thermal cameras that we got right here, these thermal imaging cameras, around the areas of interest, and then they all connected it back to 2 of the monitoring units, which were all basically connected to a laptop. So it was automated such that anytime any of the visions or the pictures that the cameras were seeing, anytime that it exceeded a predefined heat level, it would set an alert and it would set an alarm, and it would let people know, hey, this has exceeded your predefined temperature level. You need to go investigate this particular camera that's located in this particular area, right? So when they calculated the cost of those thermal inspections versus the installation cost of doing 50 cameras and 2 monitoring units, they calculated their return on investment to be 18 months in this scenario, right? So just to kind of run through a little bit, so on average, there's about 37,000 industrial fires that happen in the United States every year. They average about $80,000 a piece in terms of the damage that's done. Thermal inspection costs are going to vary wildly from, size of the facility and how many things you need to measure and all that stuff. But in this particular real world scenario, they were saying that it was about $2,500 per inspection. So on the next page, I'm going to kind of show you a real world example of where you would see this. You see a lot of these electrical fires, a lot of these fires happen as a result of the equipment inside of a control panel, either, loose connections or things reaching the end of their life, starting to fail, or just product that doesn't have proper cooling. And so what you can do is you can put one of these thermal cameras so it's pointing on all of the components inside of your control panel. And so you're going to get a live feed of the heat dissipation that is happening inside of your cabinet there, right? What's really interesting about this product is it actually has some intelligence in the algorithms where if it detects a heat rise, it will actually know what that heat rise stabilization temperature will be about 30 minutes ahead of what it actually gets there, right? So if it detects a 1 degree temperature rise per minute, it will say you're going to stabilize at plus 45 degrees from where you are right now. And it'll know that about 45 minutes in advance. There's a YouTube video up there if you just kind of Google K6PM that shows you an example of what they mean when they talk about this, just to kind of give you some more information on it, since we're just doing a high-level overview right now today. In addition to this, you can actually set alarms on all of these grid squares that you have here. So if you have a particular area that you want to say, all right, if anybody goes over 40 degrees Celsius, I want you to notify me. And so it does just that in this particular scenario, right? And so it's going to come up with an alarm that says you have exceeded a value that I have defined, and I want you to go investigate this. There's also kind of an auto thresholds feature where you can just push a button and it'll have some level of intelligence that basically kind of predicts the level of monitoring that you want to do, right? And automatically sets some of your alarms where you think it needs to be. So really cool. It kind of basically eliminates much of the guesswork out of it, where, if you kind of don't really know a whole lot about this, it's a great thing to do to get you about 95% of the way there. And then you can dial it in yourself if you want something very specific. So great way to monitor any sort of thermal profile based upon vision, and you can set alarms to do stuff. There's also transistor outputs on the monitoring unit, so then you can go and, if an alarm triggers, you can turn on a red indicator light to basically say, hey, we have a problem here, and you need to go investigate it. So last thing, just kind of wrapping up here, I wanted to mention that we have a web page on the Omron website that basically kind of covers the predictive maintenance solutions that we have in a greater level of detail. The whole point of this is basically to just get to a point where you can remotely monitor the condition of your equipment and then do analysis with that information, right? And so from there, you're digitizing that information, and then the software helps you replicate some of the, essentially the maintenance engineer's analysis of when you would want to do service on the products, the equipment that you're using. And if you noticed on the 6 products that I just talked about, these are all easy to install, easy to retrofit on existing equipment, right? It's just going to screw in or attach with a magnet, or you're going to clamp it on some wires, or you're going to install it in your cabinet. So it's just looking up at the components inside of your control panel. The whole intent is to reduce unplanned downtime and maintenance costs, and then reduce your reliance on skilled labor resources in this time where those are kind of in short supply and in high demand. So last thing that I wanted to mention real quick here is we actually have a demo case as well that is probably circulating, where it kind of goes into the function of, like I said, you can see this right in front of you, a power supply, the K6CM motor condition monitor, specifically the vibration and the temperature unit. Then we have a little motor inside of there that intentionally has a bad bearing. So as you increase the speed of this little drill, you'll get more and more vibration, and you'll see that it'll actually trigger this vibration monitoring unit to say you have exceeded this threshold that you have defined as being safe, right? And then the last thing is there's that K6PM thermal condition camera system in there. And so you can connect all this up to your laptop, and you can test all these things. You can see their function, and you could probably even set it up in your facility as just kind of an example to see how things work. It'd be a great way to show its real world application. So that's the last thing that I wanted to cover. And then I wanted to kind of hand it back to AAP Automation and just say thanks so much for setting this call up today. And if you have any questions, we're more than willing to answer them now. And if you have any questions in the future, please contact AAP, and we'll get you set up with a solution to your problem. Thanks so much.
Yeah, if anybody's got any questions, feel free to reach out via through the text box, or let us know.
Hey, Dan, Abraham here. I got a question for you in regards to the connections. I know you walked through how you can connect to the various motors. Is there a specific PLC that someone has to connect to? I mean, I know that you work for Omron. So does it have to be an Omron PLC that you connect to be able to get that information?
No, so it's just the RS-485, and I'm pretty sure that's a standard protocol, right? And so I think that's used in a lot of different applications. So if you have a PLC that will accept a RS-485 communication input, that will work with that PLC.
Any more questions? Well, that being said, thanks for your time today. The one thing I would mention is that if you do have interest or would like to discuss an application that you may have, please reach out to one of your AAP automation sales engineers. Would be happy to help. And with that being said, thank you for attending our predictive maintenance webinar, and thanks a lot, Dan, for the presentation. You did a great job.
It was my pleasure. Thanks so much for joining us today, everybody. Have a great Thursday.
Bye-bye.